Good day, everyone. My name is Mabel Mapuwei, and I'm in M² group number 13. My partner is Matthew Grobler. We are going to present to you the vehicle price prediction project. So we worked on this project in partnership with Hits Pizza Motors, which is a car dealership, and they specialize in selling pre-owned vehicles and assisting clients with funding on and all the necessary requirements when one is buying a car. So they need a solution which will assist them to assess the market as well as predict the prices for pre-owned cars. So the goal of the project was to build a vehicle valuation system that can be used to predict selling price of vehicles that are offered to their dealership. So this system will reduce the time it takes for hospital employees to investigate the value through searching online, as they had to do this manually. The approach that we use for the project, we followed the following steps, which is the creation of the scope and goals, which was based on the partner's requirements, data scraping from AutoTrader. We explored the data, compared various models, and evaluated the model using PCS. We did the model deployment. The data we scraped from AutoTrader consisted of about plus or minus 80,000 records, which is the number of vehicles you always find on AutoTrader. And we were pulling out the make, model, year, whether the car is new or used, or if it's automatic or manual. All the variables do contribute to the price of a vehicle. And these are predefined fields, hence the data is well structured and there were no redundant data. Enrichment was needed for car state, transmission, and make and model, as these are categorical variables. We also filtered cars such as armored cars and those cars which had features which were not required by the partner. So the modeling was done using regression, namely linear and ridge regression. And we use one-hot encoding for the categorical data, which we also split it into training and test data sets. sklearn library in Python was used to train both the linear and the ridge regression model. And the test data, we use it to predict the vehicle prices. So these were our results. I'll focus more on R², which explains how much the variables that we used contribute to the outcome, which is the price. And on the right, you can see the coefficients, and these are the amounts by which the coefficients affect the prices of the cars. So the mileage, normally as the mileage goes up, the price also goes down. And now to the deployment, I hand over to Matthew.
I'll quickly go through the deployment app. This app can be used by any employee within Gijs Pizza Motoring. All you need to do is select a vehicle, and I will select a Ford Ranger 2.0 turbo, and I'll select the wild track. Is the vehicle new? I'll say false. Secondhand. Is it automatic? True. I'll stipulate the mileage, and I've made it just under 40,000, and I'll say it's a 2020 model. Then the model runs in the background, and it will produce an estimated vehicle price along with all other metrics concerning that make and model. It will tell you how many vehicles there are currently on the market. It will tell you the average vehicle price, the average vehicle year, and the average mileage. This will all this data will assist Gijs Pizza in making a decision as to what the selling price of a vehicle will be. For this example, you can see that it estimated the vehicle to be 624,807 Rand. There are graphs below with traces that identify how this vehicle is priced against other vehicles that are similar. Here's an example with mileage on the x-axis and the price on the y-axis. If I were to increase the mileage and let's say I were to decrease the year, what you would see is that the tracer will move once the model has finished running. Okay, and as you can see, it has dropped down to a price of 566,000. On top of that, there is the raw data that can be extracted and used in Excel just to assist in any further decision making. Thank you very much.